Hi, good morning or good afternoon, depending on where you are. We wanted to welcome you all to this workshop. We're very excited to be co-hosting between two NIA-funded networks, the EdDem Network and the Network on Life Course Health Dynamics and Disparities. This workshop kind of originated out of conversations between our two networks among some of the MPIs about the new very welcome NIH policies around data sharing, but the challenges that come with making shareable data. Many of the members of our two networks are making data products already or are planning to make data products that they would be sharing with the research community. And so this network is really designed to help provide some guiding principles and maybe some tools to help folks in that process. We have two really phenomenal presenters who are just kind of the best around when it comes to best practices for data hygiene, data curation, and data sharing. They happen to work on projects that are mostly dealing with contextual data, but these kinds of principles apply to other data products people might be developing as well. I know some people develop polygenic risk scores or DNA methylation scores. Other people are using survey data, even qualitative open response answers to create kind of new forms of data that they'll be sharing back to the research community. The format for today's workshop is we have two presentations. Each presentation will be followed by a Q&A of about 5 minutes, but feel free to put questions in the chat along the way. And there'll be more time for questions at the end. So if you don't get your question in there in that approximately 5 minutes, no problem. We're then going to have a bit of a panel conversation with people who have gone through the very rewarding but very painful process of making shareable data. But that's actually more of an open part of the session for all of you to get involved in the conversation as well. I should probably do the thing I always forget to do, which is introduce myself. My name is Jennifer Elshire. I'm one of the MPIs on the NLC-HDD, co-organizing this with Jennifer Montez, Sarah Burgard, and Taylor Hargrove, who are the other directors of the network, as well with Katrina Walsman and Pam Hurd from the EdDem network. All right, so I'm going to go ahead and introduce Calley Fisk. She is a postdoctoral scholar. She works in the School of Gerontology at USC and also in the NIA P30 Center, USC UCLA Center on Biodemography and Population Health. So she's going to provide the first half of the presentations, which will then be followed by the next speaker. So Calley, if you're ready, I think you can go ahead and get started.
Okay, great. Thanks, Jennifer, for the introduction, and thanks to everyone in the audience today for sharing their time with us. We really appreciate y'all. So our presentation portion of this webinar will cover aspects of the research data lifecycle. And the research data lifecycle is depicted here on the slide. It involves the organization, storage, preservation, and dissemination of research study data. While there are many different components of this life cycle, the important thing to note is that they're all interconnected with one another. So the aspects that I'll talk about today in part 1 are interconnected with the aspects that Heidi will talk about in part 2 and vice versa. Our goal is to provide you with some basic tools and strategies to help you move your potential research projects through this life cycle more confidently and more efficiently. So today I'm going to focus on the right side of the research data lifecycle and discuss some of the internal steps required for producing shareable data products. The essential first step in creating these types of projects is to develop a good plan, and this includes preparing for how your project will successfully move through that life cycle. Good planning at the front end ensures that you have sort of higher quality output at the back end, and it sets you up for success. This planning process might require multiple steps. It often includes having data team meetings, meetings with people at your institution, meetings with folks at your external partners. Your external partners might include your external funders, but they can also include institutional review boards as well, especially if you're working with human subjects data. And so at this stage, we want to be prioritizing the FAIR principles for our research projects. And the FAIR principles are the 4 guiding principles for scientific data management. They were created to support the use of data, both by individuals and by software. The findability principles refer to how folks will discover your research projects. The accessibility principles refer to how users will access your data or request to access your data. The interoperability principles include not only how humans, but also how machines understand your data and if they're able to read your data correctly. And then finally, the reuse principles refer to providing the appropriate context for how to use and continue to use your data appropriately. And overall, these 4 principles provide the foundation for how data should be publicly shared, and they're a useful framework for us to consider at the beginning of our research project and then embed throughout that life cycle. So why should you care about employing these principles and planning for data management? In short, it's going to make your lives a lot easier, and it's going to aid in your ability to produce high-quality, useful data. Developing consistent and good practices will lessen the time it takes to do some of these projects. It will lessen your workload. And it's also good. It's also going to ensure that you are following good research ethics and complying with any external requirements that you may have. Most of you are going to be familiar with data management plans, and these are the more formal documentation of the process. They're typically a 2 to 5 page document that you submit alongside a grant application. In some cases, funders like the NIH that Jennifer mentioned requires a data management and a data management sharing plan. But they're helpful to have regardless of a grant application. And we can think of these plans as sort of your internal North Star of your data project. There are various pieces of information that can go into these plans, and there's no one standardized type of DMP if you're not submitting it for a grant application. And we can think of these DMPs typically as living documents. So they should always be evolving alongside your research project, and they should be revisited often. Online tools like DMP Tool are available to help you draft a DMP as part of your research project. DMP Tool provides public plans for anyone to look at, but then they also have institution-specific plans, so you can log in with an institutional login. This can be particularly helpful if you're applying for a grant for the first time and you are unsure of how others might have structured their DMPs to follow specific external requirements. And you can also search for example DMPs from specific funding agencies and from specific institutions. The tool also provides language and guidance on common components of DMPs and even prompts that you can copy and paste depending on the aspects of your data project. So once you have a draft of a DMP in place and you have your data planning underway, we can start to think about how you can create internal data workflows to ensure that you can successfully follow that plan. And so we'll talk briefly now about both the project and the team infrastructure that is often needed for these successful workflows. For project infrastructure, we'll focus on the tools, folders, and organization needed for your projects. Specifically for tools, we can think about the machines and the programs we might need to complete our projects. So some things to consider here are whether your data team can work with their personal laptops or machines. Do you need to invest in a standalone computer or server for your project instead? And then in terms of programs, we can think about not only the programs we need to produce our data and process our data, but also any tools that we might need to satisfy the external requirements for sharing our data. So for instance, with the CDR, we tend to work with Stata and R to produce our data, but then we're often creating SAS data files to share out with our external partners. And then you want to consider here whether these tools are accessible to your data team. So if you do have a server that you need to use to work on your project, how are you handling the fact that maybe multiple team members need to access the server at once? Do you need to train folks for certain types of programs or for using certain types of machines? And how do you account for that in your data management plan? Folders are where your project lives, and often we're saving our projects in some sort of shared application so that multiple members of our team can access the projects. Typically, things like Dropbox and Google Drive are used here, but also sometimes the combination of the two. So for instance, at CDR, we primarily use Dropbox, but we also share project documents via Google Drive, and so we are constantly needing to cross-reference between the two. Here, it's necessary to think about a structure that is accessible to you and your team, but that also provides the appropriate storage that you need, satisfies any institutional agreements that exist, and can handle the different file types you're producing. You might also want to have an idea here about how you might back up or version control or destroy your data. Heide is going to talk more about that in part 2. But it's important to note that some forms of automatic version control exist with some platforms, and so that might be a consideration as you're deciding where to house your data project. Wherever your project lives, it needs to be well organized, and having a well organized and maintained project folder allows for better findability and accessibility of your data for your data team, following those FAIR principles. Here we want to plan ahead of time to create a folder structure with kind of an agreed upon format that your team feels comfortable using. And some important considerations include striking a balance between deep folder structures, where there are multiple subfolders that lead to 1 or 2 files, versus shallow structures with few subfolders, but with multiple files within a folder. You also might want to consider consistently naming your folder and files, maybe numbering your folder or files that need to be run in a particular order, and then making team decisions about archiving files you no longer need. So here's an example of folder organization from our work with the contextual data resource. We have standardized READMEs for each of our project folders that overview the files in each folder and subfolder. We also number the folders to refer to the different processing steps of our data management plan. And this is particularly useful because not only can folks use this README to find the necessary files that they need, but we can also reference these standardized foldering systems as we work on the data in our coding scripts. So this is a really helpful document to have. Moving on to team infrastructure, we'll focus on the data team and communication within the team. So typical roles for these types of projects include the investigators, the data coordinators, the data managers, project team members, consultants. It's important to build a team with appropriate skills and expertise, and that might be dependent on the time commitment that is needed from team members. That might be dependent on the time that you anticipate your project taking. And then once we have a team in place, we need to communicate and document the roles so that the team can develop standardized workflows and efficiencies. Here we want to think about not only how we communicate tasks in our project meetings, but also how you might communicate day-to-day tasks, especially if those tasks have dependencies or have multiple hands on those particular tasks. Here, there's project management software that can be particularly helpful. So software like Slack, Asana, Trello. At CDR, we tend to use Slack for our day-to-day updates, but then we also have consistent project meetings where we talk about major project updates as well. For both building your team and communicating with your team, it's important to consider the timeline of your projects and if your team will need to change over time. So oftentimes we want to have succession planning in place where you can smoothly offboard and onboard team members as they move on and off projects. So here's an example of how we communicate some of the status of our projects at CDR. For this workflow, we use Google Drive to provide updates on main project milestones. And you can see here that our rows are individual products. For your projects, if you're only working on one data product, your rows might include the components of the data lifecycle instead, or different aspects of the project. But here we have an embedded README into the workflow diagram so that everybody knows what this workflow is telling us. We have columns that define our project teams and managers. We have columns for the status of different processing steps. And we use Google Drive so that multiple team members can edit this document throughout the week. And then we can also pull up this document as an agenda for our project team meetings. So wrapping up data workflows, the main point here is to keep in mind that you want to build infrastructure that emphasizes routine and automation rather than adopt one particular strategy. It's also often good to anticipate more versus less at the front end of your data project so that you're not sort of reinventing organizational schemes throughout the project. And then finally, this type of organizational structure only really works if people are invested and use the system. So the README files only work if people update those files as they update files in the folder. The workflow only works if people are constantly updating that Google Drive as they make progress on projects. You can't just put the rules in place and totally forget about them. All right, so let's wrap up part one of the presentation and talk about some data organization steps. Data organization decisions will depend on the type of data product you're going to be producing. And so it's helpful to have an idea from the beginning of what your data currently look like and what you eventually want your data to look like. And so here are the main buckets of data organization that we'll cover in the next few slides. And some of this will dovetail into Heide's part two as well. So this will be a nice setup for the rest of our time together. For variable naming conventions, there are some good rules of thumb for variable naming that are going to make your life easier as you prepare to share your data. The first is to create a unique identifier, and we can usually create one that matches to the variable we plan to link to other data sets. So for instance, with CDR, we work closely with HRS data products, and so we're able to embed that same identifier that the HRS uses into our CDR projects to make that linkage easier for our team members. Other variable naming conventions include to be brief. So you want to keep in mind character limits of different programs. If you're producing data files for R, Stata, SAS, you want your variable names and your variable labels to be able to carry over into those different programs. All of your variable names should be unique, both in the same data sets, but also in data sets across products if you're making multiple data products. And you want to overall just be consistent with your data naming. So be consistent with how you identify time in your variable names, how you use capitalization, how you use different characters. And then another thing to note is that you may need additional what we call housekeeping variables that are not included in the sort of raw data set you might be processing. These variables can be particularly helpful for your end user to access and understand your data. But they may exist outside these more consistent naming conventions. So here's an example of a data dictionary from one of our CDR data products, and the columns of the data dictionary refer to different components of what will eventually be the final variable name and labels. And so you can see here in column A, it begins with the stub name for all of our variables, and the stub name is referring to whether the variable is a number in percent. And then we have other columns referencing the geography and the year of the variables. And we employ this setup to create a variable name that looks something like this, where we combine the components of the columns in the data dictionary, and this naming convention then can be consistent for any year or geography changes that might happen. And if we create a standardized naming convention like that, we can refer to those components of the variable name in our code. So this is a section of Stata code where I'm applying labels to the variables in the data dictionary, and I'm able to reference the different components of the variable name, like the stub name, the year, the geography, to streamline my code for all of our variables across all years. And it makes my life a lot easier. Once you've finalized your data, you'll want to have plans in place for how you handle data updates. So new versions might happen if we identify errors in our data, and it's helpful to have a validation process for your data prior to release to catch some of those errors. Versions might also happen if you add new years of data or new variables to your data. So it's important to identify what a new version means for your specific project and to be consistent about that. Here, it's helpful to have data dictionaries, data cleaning plans, README files to handle these inconsistencies or manual changes. And overall, we want to make sure we're keeping a change log of any versions of our data. This allows users to understand the history of our data, to be confident that they're using the correct data as well. And I have an example here on the slide of a change log for one of our CDR projects where you can see that we're noting the different changes that we're making to the different versions of the data. When you're preparing your data for final formatting or release or those version updates, you want to identify prior to data processing what the final format of your data will be. And this includes both the file type, but also if your data needs to be in long or wide formats, and then any other processing decisions. Prior to release is also a great time to do those data validation practices. So you might be estimating summary statistics, eyeballing your final data, creating graphs. At CDR, we typically have a data team member that wasn't involved in the processing of the data do these validation steps to just ensure we have a second pair of eyes on what we're doing. And again, we want to be tracking any releases of our data products so that we have a history of who, what, and when we distributed our final products. And I'm going to end here on internal and external documentation. Heide is going to talk more about this step as well. The big takeaway here is that internal documentation specifically is a major time investment. If possible, you should account for that time investment and those efforts in your proposed project plan and budgets. In some cases, creating these types of documents are more work than actually processing the data. And there's many different types of internal documentation, as we've seen examples of throughout part one. So for your team, you could have onboarding and offboarding documentation, governance rules. You might have data inventories or code for data processing, style guides and change logs for data management, data dictionaries for variable decisions. Overall, most of the internal documents you'll produce are also considered living documents that change with the project, and again, they need to be revisited quite often. So here's an example of an internal, what we call cookbook of our CDR projects, and this is where we overview the original data, the expected data product we want to produce, and the data processing steps. And you can see here that there's a lot of information in this internal documentation that doesn't make it out into the external documentation. So for this particular project, our external documentation looks something like this, where the information provided is geared towards the end user and not the data team. The takeaway here is that the higher quality external documentation you provide tends to matter for the likelihood of people finding, accessing, and using your publicly shared data. And the public sharing part of our data products is where Heide will take over. So I will end my part one here. And I think we have a little bit of time for a brief Q&A.
Yeah, please go ahead. This is Pam Hurd. Please go ahead and put any questions you have in the Q&A, or you can just put them in the chat too, if that's easier. We have a couple minutes here for questions for Calley and her fantastic overview. I guess I can briefly start. Could you talk, Calley, about what you think that you did an excellent job kind of walking through all these different steps and in the process. What if you were to sort of pick one out as like, here's where we sometimes run into the most problems. Would there be a point in that process where you're like, gee, this is a stage where you have to pay particularly close attention because it's easy to make mistakes, or there's some other kind of part of that process that's difficult?
Yeah, I think the most difficult process, I think, is actually just keeping an eye on all of the moving parts that are happening and making sure that that documentation is happening correctly and is being updated. So sometimes you're having team members go and do a bunch of work, and then it doesn't get into the cookbook, or it doesn't get into the README file, and then you're having to update it after the fact and trying to figure out, oh, what did we do again? Why did we code it that way? Where did we download that file? And so I think that is a big takeaway message of when you do something for your data processing steps, you should consider that documentation process as part of that step. It's not a separate step, it's included. And so don't put your data project down and go on vacation and come back and think you can produce your documentation well. You should just do it all at once and make sure everything's continually updated.
That rings true to me. Okay, we do have a question here. Oh, sorry, it's more a comment that they very much appreciated your advice and also things that I see PSR recommends for their data providers. So that's great. Okay, well, thank you very much. We have, towards the end of the session, we're going to have a panel where we'll have lots of opportunities for people to chime in and ask questions. So why don't we tee up next Heidi for the next presentation?
All right, thank you very much. Give me just a second to share.
Okay, Heidi, I was going to introduce you if that's okay.
Oh, please.
So people
Thank
know,
you, Katrina.
people know how great you are. So, okay, so just briefly, I'm really happy to introduce Heide Jackson, who's the director of the Scientific and Technical Core at the Maryland Population Research Center. They're also an associate research professor here at Maryland. Heidi brings deep expertise in secure data analysis and research computing and serves on the board of the UMD's Federal Statistics Research Data Center and Michigan's DSDR Steering Committee. And they're also NPR's data custodian. And before that, served as a statistician at the Census Bureau. So on top of all of that, I just want to say that from working personally with Heidi, I know how much they care about making data usable, accessible, and replicable. So I'm really looking forward to learning from them today. And so with that, I will then turn it over to Heidi.
Awesome. Thank you very, very much, Katrina. And I'm really looking forward to talking with everyone and learning from all of you the excellent projects that you have ongoing. So let me see now. All right. Can everyone see okay? Okay. So today I'm going to be talking about some best practices when it comes to publishing, disseminating, and maintaining data. So Calley talked about the right-hand side of the research lifecycle, and I'm now going to pick up right at the left-hand side. So specifically today, we're going to talk about the transition from an internal project and one that's sort of internally facing to an externally facing project, and one that's going to be engaging with the public and data users. We're also going to discuss some key terms to know for data sharing as you work on your data sharing and management plans that Calley discussed. And then finally close with talking about the process for planning for data use and reuse on a more long-term basis. So first, we're going to start by talking about some of the steps for moving a project sort of internally facing to externally facing. And one of the most important considerations that I'm often thinking about are human subjects. And if you're working with contextual data, human subjects may not seem immediately relevant. You might be thinking, this is contextual. I have information about a neighborhood, about a community. It doesn't really identify people. But there are some circumstances where even contextual data can potentially increase the re-identification of individuals. Specifically, if you're working with data that's extremely recent, If you're working with small geography, say down to the census tract level, in a dense place like New York, maybe that's not an issue. But in Idaho, if you're releasing census tract data, there might be a very few number of people living in that tract, and so it's potentially identifiable of people. And another consideration in which human subjects can pop up in contextual data is if you're working with really rare events. So if you're studying a disease that's just not very common and you have a small geography, that information together with other information that users might potentially bring in, and if you think about all the data that's out there and can be linked to your data, creates a potential risk for re-identification. And I think as you move from an internal to external facing project, that's a good time to be thinking about those risks. So there are a number of strategies we can think about as we move to a public facing project to minimize human subjects risks and sort of maximize our protections. So among these are thinking about aggregations. So if internally you have a project data set that is at the census tract level, you might think about aggregating up to the county or city. Another option is suppression. If there are particular variables or coding schemes that are just have a really high risk of identifying people or a particular sensitive, you might think about leaving those variables off of a public use file. Another strategy to think about for continuous measures is top or bottom coding. And this can take on a number of forms, but let's say you have data where at the 1th percentile, those people might be really, really unique. And so you might want to either perturb data after a certain percentile, say the top 1% or the bottom 1%, such that individual responses can't be re-identified, or you might want to truncate your distribution if those outliers maybe aren't meaningful. And if you find in thinking about human subjects, you need to make considerable changes, it's worth thinking about whether in addition to a public use release, you might want to think about a restricted data release. And this would be a situation in which you make the data available, but it's only available to approved researchers who submit a request. And another feature to be thinking about as you move a project from internally facing to externally facing are data destruction and retention requirements. And these will really vary and be very situation and project specific, but many times institutions, data providers, and other stakeholders might have rules and governance around how long you need to retain data and when it needs to be destroyed. So it's really important to know the timeline if you need to destroy the data. And whenever I get those kind of emails in my inbox and I have a date in which the data needs to be destroyed, I always send an email to myself just to know that I need to destroy the data by this date or request a renewal. And if you can, it's really good to automate this data destruction if possible. So if you have a job on a server, you can set a script to automate a data destruction by a certain date. But it's worth noting there really is no one correct way to destroy the data. And when you learn about the timeline for data destruction, it's really important to know how to destroy the data and what constitutes destroyed data. So there are different strategies in how gone the data is and how much can be recoverable. And different stakeholders really have different regulations about this. And also sometimes you might need to document this destruction. So if your institution or a data provider that you're working with has rules around that, it's a really good time to be thinking about that. And I really like thinking about data destruction and retention as you start thinking for a public-facing project, because once data goes out there, it's really hard to get back. So if you release data that you don't mean to release, there's really no way to sort of unring that bell. But if you've been doing the sort of good project management techniques that Calley described and have really been thinking about the data that needs to be retained and destroyed along the way, that really minimizes the risk of data getting out there that you don't want to be out there. Another feature that Calley discussed, so I'll be brief here, to be thinking about as we move to a public-facing project is documentation. And so Calley really showed some nice examples of how we can add polish to our documentation, but just a few more things. One factor to consider when we're working to make our documentation public-facing is being mindful and avoiding any internal project jargon, thinking about how we can make the terms that we use accessible. And in addition to how we describe the data with words, it's also really important that when you make your public-facing documentation to do any calculations or crosstabs, using the public use version of the data. And there are two really important reasons for this. One, if your crosstabs in the public data don't match what users are seeing in the documentation, this can really create confusion and issues of use and reuse. And the other is really a human subjects concern. If you've done work to de-identify data and make a public use version that doesn't have these sort of small cells or other issues, you don't want to accidentally release those as part of your documentation. It's also a great practice to consider examples for suggested use, how you want users to engage with your data. And here specifically, we want to think about examples for sort of basic data manipulation and best usage practices that you want users to use. And consider examples not only in the software where you were working, but across a wide range of software packages that your users may likely be using. And this is something that I really like that IPLMS always does with their data releases. They put out how you would set the weights in R, Stata, SAS, and I think increasingly now Python. But the idea is to really be broad and think about how users might engage with your data, and just to do some checks of someone on the project team to make sure that your weights are compatible across a range of software packages. Another step in moving towards a publicly facing project is thinking about project branding. So you may already have a name, but just think about whether a project name, short acronym, an identity, maybe a logo, and also be thinking about ways in which your project can engage with the public and to connect to your users. So one really useful step is to develop a project website if you can. Social media accounts are also really helpful in getting the project out there and providing users with information about data releases, as well as an email listserv. These are all strategies that you can potentially implement in order to sort of raise awareness of your project and data that's coming out. And once you've done some of that preparation from moving the project from internally facing to externally facing, it's really time to be thinking about how we can make the data public and how we can develop a document to funders showing that. And so Calley really talked about the DMP, the data management plan, and I'm going to be talking about sort of the externally facing version of that, which is the data management and sharing plan. And their content and length really are determined by the funder. NSF and NIH both require these, and increasingly some foundations do as well, which I think is great. Data should be free and out there. But unlike data management plans, which is a document you really want to revisit and come back to and should be a living, breathing document, the DMSP really should be a static document. You hope that once you write this out, it won't need to be changed too much. And this is something that you typically submit with a grant application. So once it's finalized and approved, it's out there and it's with the funder. And so that also, I think, changes a little bit of the tone in how you write these, because you want to think about what you can commit to releasing, being mindful that this document probably won't be changed too much. And here are some examples of NIH data management and sharing plans, as well as the NSF version. The elements they ask for are very similar. There are 5 elements. The main difference is NSF's is limited to 2 pages, while NIH is not. And NSF also has some division-specific guidelines about how they expect these to be completed and some of their preferences in terms of data sharing. A lot of the elements of these plans are things that Calley and I have talked about before and things you're probably familiar with, that what data you're going to generate, how human subjects are going to be protected, why you're doing this. But there are a few key terms that as you're filling out the data management and sharing plan that may be less familiar. So I want to talk about them quickly. So the first of these is metadata. And I always think of metadata as data about data. It's really information about the data collection that helps others find the data and use them. And really, oftentimes, metadata is geared towards computer systems. And the metadata should be structured so that it follows specific guidelines, such as the Data Document Initiative or the Dublin Core. And this really aligns with FAIR principles so that your data is always findable and accessible by machines, and really helping digital systems classify and identify your data. And there are templates out there if you need to make this yourself about how to do it, but oftentimes it follows to the sort of XML format, and it's really read by computers, and it's to help users and systems really classify your data and do that on kind of a long-term basis. So there's a catalog of your data, who put it out, what the title is, and what it contains. Another key term that you'll see in the data management and sharing plan is unique persistent identifiers. I often use and see the term more often digital object identifiers, which are the same concept. DOIs are regulated by the Digital Object Identifier Foundation, and they provide a persistent and unique way to identify your data, even as technology changes. So you may have this for publications, but data sets get them as well. And digital object identifiers are really important as serving as your public-facing identifier for the data and project version control. So you might have multiple releases of a data set that goes public, as Calley talked about on the internal side. On the public-facing side, what you might do is when you update a version of the data, the DOI will also be updated for a new version. And this is really important for thinking about the replicability of analyses, because you want to be able to identify what data users were using, and the version really helps you do that. And a final point that I think is really important is when it comes to data sharing and making your data get out there, it's really important, I think, to think about sharing the DOI in a suggested citation rather than posting your data in multiple places. And I'll talk about that in a bit, but that's why DOIs are nice, is they're a shorthand way to find your data and make sure it's consistently accessible and documented if there are changes over time. And then a few other key terms that you're going to see in the process of completing a data management sharing plan are the data repository, which is just the place where your data is going to be held. The data deposit, which sounds like a bank deposit is a one-time thing, but is actually more involved and can often take months and several steps. And it's the process by which we sort of submit the data for dissemination through a data repository. And finally, you're going to be thinking about data curation, and that's just the process and maintaining of the project data that might be done by you or the data repository. And that's a consideration we might talk about a little more in the Q&A. So what actually goes out and what gets shared with the data repository? So this really depends on the repository. At a minimum, you'll want to be sharing documentation, data, and metadata. But the structure on which this takes and how involved this is really is going to depend on your project as well as the repository. And on the right-hand side of the screen, I've just included the ICPSR depositor checklist that gives some examples of what ICPSR, one of the repositories I'm going to talk about in a second, accepts in terms of their documentation and data sets, and has some details on the formatting. So different repositories can have different requirements on this. And that also influences sort of what documentation you submit and the format that it takes. So in terms of data repositories, there are a number of fantastic options out there. I won't have time to go through all of them, but I just want to share a couple on this slide. I did want to talk about one data dissemination technique that I don't recommend, which is posting data directly on the project or department website. It's great to have a website. I think websites are incredibly important for sharing information about your data, having suggested citation, but a project or department website isn't a great place for actually storing and hosting the data, simply because oftentimes they don't have the data backup procedures in place that a repository does. They don't have the systems to make your data findable in terms of processing of the metadata. And this is something that NIH has strongly recommended that people move away from. And it's really moving it towards as established data repository, and this will really depend on your particular subfield. I use GitHub all the time for code, but something like ICPSR, Open Science Foundation, for some data set deposits and repositories. So there's a lot to think about when selecting a data repository, and I want to talk about a few of these considerations. One chief among them is funder requirements. Usually NIH and NSF don't suggest particular repositories, but NIH, for example, has a list of repositories that they support. And so if you deposit at one of those sources, the process is generally easier than a repository that's not listed on that source. However, there's also the popularity with your user base to consider. Where are users going to be looking for this data? What fits? I was recently working with someone who was looking to make a data deposit, but their user base really was looking at a repository that wasn't on NIH's list. So that was an interesting back and forth as we worked to get that data deposited in a repository that made sense for the user base, but was less known to the funder. And there also might be institutional partnerships that you might want to consider. So your research librarians and the data libraries and data science might have suggestions here. This will really, again, depend on the size of your data. For smaller data sets, there might not be considerable costs. But if you're doing something really specialized or really large data sets, many institutions have agreements with particular repositories that can help reduce costs to the project and potentially the end users. There are also some specialized repository features related to that you might want to be thinking about. One of them that I mentioned earlier are human subjects. So if you anticipate that you might need to have a restricted data release, having a repository that can support that and has a process in place for allowing restricted data is one factor that you can consider when thinking about what repository to use. And finally, their issue of costs. And generally, I think it's best practice to have data be free and publicly accessible. However, for the case of restricted data in particular, sometimes there are considerable costs for maintaining virtual machines that approved researchers might use. And so you might want to think about, are those costs going to be going to the project? Are they going to be going to the end user? And that's another factor in this sort of calculus of selecting a repository. And so as you're also thinking about this decision about what repository to use, it's also important really to get information from a funder. So on the left-hand side, this is NIH's desirable characteristics for data repositories. And this gives you an idea of what NIH is looking for when you select a repository. And they have a number of recommendations here, and they also have a search for NIH supported data repositories, so you can also look of where you're considering depositing the data is on their list. And if it's not on the list, you can write the data management and sharing plan such as to justify why it's appropriate, that it meets these characteristics for a desirable repository. Oops, sorry, my slide froze for a second. There we go. And additionally, there are some questions to be thinking about to ask a repository as you're making this decision and as you're thinking about it. So I'm not going to read through all of these questions on the screen, but I just want to touch on a few issues that I haven't talked about yet. One question that you might want to think about asking is whether a repository allows an embargo period. And this is really important if you're going to be having a paper coming out that will accompany the data release. You want to see if they will embargo the data or make it available to a limited set of users until peer review process is complete and you can release both the paper and the data set. It's also just worth thinking about how a potential repository that you approach answers these questions. Sometimes it's less the specifics that I care about, but if I ask sort of a repository like, how do you handle your metadata? What standard do you follow? And they don't have an immediate answer, that might be a sign that a repository may be less established and they're less used to working with some of the FAIR principles, and that would be a potential concern. I've also included kind of on the bottom right-hand corner of this screen, a comparison of generalist repositories, and this is a product of an NIH working group, and it's a very detailed and comprehensive list that kind of goes through some of the size limits, restricted data release, and how much the repository is involved in sort of data curation, which is another feature that you might be thinking about. Specifically, how much is the repository going to be doing in terms of doing things like generating your suggested citations? How much do they support the users, or how much do they defer to the project? And there are some trade-offs there in terms of selecting a repository and just thinking through some of these issues. So with that, I really want to open it up to the group, and thank you very much. I look forward to your questions and thoughts.
Take a minute, and if folks have some specific questions for Heidi, we're going to do the panel discussion next. But any specific comments about Heidi's talk, please go ahead and, I'm sorry, I'm not on video. Please go ahead and put them either in the chat or the Q&A. And while we're paused here for a minute, I'll ask Heidi the same question I asked Calley, which is, in this process, where are some unexpected like hangups or difficulties you've encountered?
So I think one of I think I was not anticipating how extensive a data deposit would be. And this was something we were working with Katrina recently on the contextual data resource, is how many steps that would be, and all of the little decisions that you have to make in terms of determining if the data set can be embargoed, how do you actually get a link to reviewers, and then also balancing the fact that the data want to be public. So I think it's really just planning for that data deposit as a process. And even after the initial deposit, it really does come full circle, because you might want to update the data and go back and make these updates and think about a way that you can have version control and establish way of finding the project.
That's great. We have another question here in the chat, in the Q&A. Calley, do you have any recommendations sorry, this is for Calley. Do you have recommendations for ensuring the team members maintain fidelity to the management plan?
Yeah, I think a great
That
recommendation.
is such a good question, by the way, I just have to say.
Yeah, great question. So I think first and foremost is having those lines of communication open, and making sure there's consistent team meetings and that all of your data team feels comfortable in the roles that they're assigned. So for instance, you might have team members that are more senior than others. They might take on manager responsibilities. And so what is their sort of expectation when they're managing more junior level folks that might be less aware of these FAIR principles, less aware of the importance of maintaining good data hygiene. So yeah, I would say communication first and foremost, consistent project team meetings, and then kind of clear expectations from all of your team members. And then also meeting your team members where they are too. You don't want to assign your junior members something that is maybe gonna get them into trouble or too deep of water.
Yeah, and if I can just add, I think people's ability to have high fidelity to a management plan already assumes that there's a very clear plan. So I do think people struggle when the organizational system is not fully in place or it's being adjusted a lot. And we went through all those growing pains. Sometimes we have a new system and Calley has to re-educate me to make sure I have high fidelity to it and I'm the PI on the project. So I think Calley's answer is exactly right. It's just like constant communication, because these things will evolve over time, no matter what.
Okay, we're going to do one more question before we move on to the panel discussion. How do you begin to conceptualize what the data management needs look like? How do you think about naming structures and processes? And as this person noted, I think this is right. It feels so hard to map out ahead of time, and sometimes it's hard to know what those steps are up front. So I think either Calley or Heide, whoever feels best equipped to answer this question.
I can jump in once I got myself unmuted. So I think to some degree, that's kind of the purpose of this webinar, is to help y'all think about what you need to anticipate. Because definitely when I first started to work on these types of products, I wasn't as smart ahead of time to be making these what seemed like rather small decisions of naming a variable and making sure that that was something that actually was a step that I could use ahead of time and make my life easier. So yeah, I think you want to think hard at the front end about what your data what you want it to look like. And so a lot of times when we start some of these projects and we take on new products with the CDR, we will map out like a dummy data set of variable names, what the anticipated values are, if we need to do labels, things like that. And so that can be helpful in terms of trying to conceptualize some of the data organization. Heidi, I don't know if you have any other tips to add.
No, I think that's exactly right. I will say, I think too, though, that once you're planning for a public release, that also presents an opportunity to figure out, once you've used the data and done this evaluation, what worked and what didn't. Because odds are you're going to have both an internal file and then a public use file. So you'll have those and you'll be able to develop those for the public use data once you've done some of that preliminary testing that Calley described. And that will hopefully serve as a useful backdrop in order to developing this for public use once you've kind of learned, or at least in my case, made mistakes with the data and figured out how to make it more transparent and readily usable.
Okay, great. Thank you for both of those really fantastic presentations. I feel like I learned a lot too. Let's move on now to the panel discussion. We're going to add a couple of experts here, which we're excited to have on here, especially two experts more broadly in terms of thinking about especially the addition of contextual data to data sets. So first up is Taylor Hargrove, who is now a professor at the University of Maryland College Park after a recent move. Congratulations. And she is an expert on health disparities over the life course and has worked with AdHealth in terms of helping them and leading projects around their data curation, data addition, and data releases. Our second expert is Jennifer Carras-Montes, who is a university professor at Syracuse University and has kind of pioneered generating a lot of social policy context data at the state level for folks to think about policy determinants of health. And so we're delighted to add both of them to our panel discussion. I'm going to start out. So the way that we're going to do this is we're going to take about 15 minutes for the panel, 15, 20 minutes for the panel. And then folks in the audience, so please do be thinking about questions you want to ask. And you can even just start adding them to the Q&A or to the meeting chat as we go. So I'm going to start out here with the first questions, which pertain to challenges in creating contextual data products. So the first question for the panel is, what are some of the challenges you've encountered when building contextual data sets, especially for public use? How do you handle geographic or temporal inconsistencies in contextual data, for example? Especially when thinking about harmonizing data and creating shareable data products. So whoever wants to pipe up first, go right ahead.
I can start us off, and thanks so much, Pam, for that introduction. And this is very relevant right now because I'm currently in the process of creating yet another contextual database to be merged onto AdHealth. So we're still really deep in the data management process right now. And I think one of the biggest challenges that has become more apparent is knowing what to do with the amount of missingness that can come with publicly available data sets and the extent to which some measures or variables even are meaningful if they have, a certain amount of missingness. So it's this balance of trying to provide as much information and detail and, sheer amount of variables as possible, but making sure that they're actually meaningful for users and they can be used in different analyses. And so we've had several challenges with just handling the sheer amount of missing data, as well as figuring out which values are actually plausible. So I think it was Heidi that was talking about either top coding or bottom coding, and apologies if it was Calley. But thinking about if those values actually make sense, are they really on the high extreme, and then does that then become identifiable for your respondents, or what could have been some kind of calculation error prior to this particular organization or institute releasing the data. So I think that's been another challenge of figuring out where that kind of line is between plausibility and implausibility.
Jennifer, even though there's multiple Jennifers on here, Jennifer Carras-Montes, do you have anything you want to add to this?
Sure, I do. So I'll just say, my experience with contextual data is a bit different in that, as Pam said, I focus on state policies. And so we don't have some of the issues that we talked about today. And I'm kind of counting my blessings that, my contextual data is free of those. So we started the State Policy and Politics database in 2021. That was our first release. And we update it every 2 years with new years of data. And sometimes we update it in the middle of the year if there's a new policy variable that we found. So that's our kind of frequency of updates with this data set. But some of the main challenges that we've encountered is that we have to draw from so many other data sets. And sometimes we create our own policy variables, but a lot of times we have to probably pull from 20 different data sets. and aggregate their policy information into this one big set that we think is really important for predicting health. So that can be a challenge. And one, just finding the contextual data that's contextual policy data that's relative to what we're doing, and putting your trust in that data creator, that what they've created in terms of those policy scores are accurate. And another thing that we deal with, and I think this is probably not limited to the state policy data, is deciding what measurement of that contextual variable is actually the most important. So for example, we think EITC is earned income tax credit is a very important variable for our data set. Well, what kind of measurement would we want to create for our users? Is it just an indicator of whether or not the state has an EITC at a given year? That's very easy for us to find. It's, we're positive that data is correct. But more than likely, our users want something like the generosity of the EITC in a given state, or something about the actual, configuration of that policy. They want something deeper. And that then opens us up for, it's a lot more effort to create the variable, and opens up the possibility for error in creating it. So we're always trying to balance this. How can we get a measure that we know is accurate and easy to use, and can we make it a little bit more sophisticated, and perhaps more helpful to our users? So those are the two main challenges that we deal with in this data.
I wondered if either Katrina or Jennifer Alshire wanted to chime in here, in that both are also creating these sort of contextual data resources.
I think my biggest challenge was that I'm doing a historical database that goes all the way back to the 1920s. And so being able to find those reports and make sure that they're the correct reports, and figure out, these are like 600-page reports, which variables in there I want to extract, because it's not just an electronic database, it's actually old PDFs that were typed. So there was a lot of labor to get that data out into like something electronic that somebody could use. So, and of course, as Jennifer Montez said, that because I'm the one creating this database, I'm making a lot of decisions, may not be the same decisions that a different user might make. And so making sure that we're documenting our decision-making process so that people understand why we came to a particular decision. I think that all of those things end up taking a lot of time, and probably more time than I thought that they would take. So
I think part of what I'm hearing here, right, is that the challenges to some extent can be particular to the kinds of data you're collating to share. Just a follow-up question, which is, I'm wondering how folks think about sharing, both archiving and sharing multiple forms of your data. So, right, as you update, either correcting errors or either adding new data. I wondered if folks wanted to mention briefly how they think about that process, and I include Heidi and Calley in this too.
So what we've done with the state policy database is we have a section in the code book that explains any change that's been made in between versions. But we also only post the most recent version on the repository. And based on Heidi's discussion, I'm thinking now we should probably be posting all historical versions. We retain those internally, but we only post the most recent one. And that sounds like that may not be the best practice.
Yeah, so for the contextual data that we produce for HRS, which I know direct the data linkages there, we always in our documentation, so Calley does this work, she leads on this, we, just like Jennifer said, include a section that explains why a new version might be different than an older version. For us, it's usually things like some county boundary changes happened, or like in the last census, I think it's the state of Connecticut changed their county names back to the old, like some historical geography that I found shocking and surprising, but states get to do what they want to do. But just to make sure that like users don't get tripped up. But for HRS users, we always leave the archived versions there so that they have full version control, because, you know, if someone has to go back to an analysis at some point, it'd be really hard on them if they didn't have the old version available suddenly. And for us, it's different because our data are made available in enclaves, so no one ever really gets the data. So HRS has made a decision to provide the archived versions as well.
Thank you. That's great. And certainly the projects I've been involved with tend to do it that way as well, in part for that very reason. People get crabby when they can't access files they've already run things on. Okay, the next question for the panel is about workflow and infrastructure. So how do you structure your team or processes to manage updates? Oh, sorry, which we've talked about now, which I just talked about, but a little bit more specifically to that topic is how you actually structure your team or your processes to like manage those updates. And if you have any particular tools, platforms, anything in particular in the nitty-gritty that you could provide advice about on that.
Yeah, Calley, I don't know if you want to answer that. I mean, Calley actually really kind of pioneered a process we had, or not pioneered, we made it. She heavily refined it so it is now usable and functional.
Yeah, I think some of my approaches to creating a good workflow for CDR has just kind of tried to make everything as transparent as possible and as accessible as possible to the data team. So I never really want anyone to email me. I want them to always have the info, either as like you saw in the workflow, like an embedded README or something like that. I want people to be familiar with the structures we have. So Jennifer mentioned like a lot of times at our CDR meetings, we're doing a lot of like teaching each other, oh, I've made updates here. I did a change of an organization here. This is what we're going to do now. I also try and cross-communicate as much as possible because we do tend to use a lot of different platforms for our workflow. So we're using Slack, Dropbox, Google Drive. We have a Zoom link. And so setting up those systems to be manageable. So in Slack, you can create a whole sort of like project notebook in Slack that can link to people's emails. It can link to a to-do list. It can link to pinned messages for the Zoom link. And so just making sure all of that is front facing as much as possible. And I think like both Heidi and I kind of mentioned in both of our parts is that there's lots of different ways to do a lot of this work. And so it's really about finding a way that works well with your data team and not sticking to one particular strategy.
Anyone else want to chime in on this? One thing I'm hearing is good communication with team members in terms of all of these processes, I think. Okay, my next question is about metadata and documentation. So how much documentation is enough for contextual data to be truly reusable? And how do you decide what to include, that balance between providing too much versus providing not enough, which can be tricky ground. So I'd love to hear how folks think about that.
I think part of that balance or is considered is how much detail would give away certain identifiable characteristics of respondents, right? So in our case, if we're working with block group level data or track level data, if we describe particular tracks or blocks in too much detail, right? Someone in theory could go in and say, oh, this participant is living in this particular block group or census tract. And so I generally like to err on the side of providing detail into the thinking behind certain decisions that we made when constructing the measures, or which measures to actually include in the data dissemination, but also being careful not to give so much detail that then you risk deductive disclosure for your participants.
I think for one thing that I considered how much detail to provide in the code book was because we were extracting data from historical documents. And so there was, the level of documentation is not necessarily that extensive, right? Like so what we decided to do was to at least list the exact table from the PDF document, so that if we decided not to release the data that wasn't cleaned, or we hadn't imputed. We were going to make it as user-friendly as possible, but we did want to point the user to the actual table in case they wanted to go back and look at a specific year, specific table, so that they could see it. And so we made some changes like that, so not overwhelming the user, but also providing enough background information just in case they were someone, I think of like Heidi, who's super curious about things and might want to go get the original data. So that was kind of how we balanced our decision making.
We used
And I was actually, oh, sorry, Katrina. I was going to chime in there and actually say that this is something that I think goes in both documentation and the data, or flags. So if a variable has been touched, if it's been imputed, if it's an implausible value, having that both in the documentation and then in the data set for people who don't read is a great practice, just to try to help with that, so that if users want to go back, they can. So flags are definitely something, and flags are just these sort of variables that can take on values depending on if something is touched or observed, but that's one good strategy as well.
Jennifer Carras Montes, I saw you unmute, but maybe.
I was just going to say that we use an approach similar to what Katrina mentioned. We follow the Burfus codebook structure, and in the notes section, we give users everything they need to know to either access the original variable that we drew from, or create the variable and all the websites and table numbers and things like that. And we've used that as a test every time we update the data. So the person who updates it has to start from the code book, and if they can reproduce the data, we know we're still in good shape.
Great. Okay, we're going to move on to data sharing, repositories, and thinking about reuse. How did you all decide where and how to share your contextual data set, and what role did repository requirements play in shaping those choices?
Okay, so I'll go because I just deposited my data. So I think one of the goals that we had was to get the data peer reviewed before we provided it to the public. And so we went through a peer review process, which required that the peer reviewers have access to the data. And so that forced us to use a particular type of repository that the journal supported, at least during the peer review process. But then we also thought about things like, who is this data set going to be of interest to? Who's going to use it? So some of the things that Heidi had said. So we thought open ICPSR was since it's already gone through peer review through a journal, we didn't need to necessarily go through the huge process of review that the ICPSR repository goes through, and we wanted to get it out as soon as the paper was published. That's actually a requirement of the journal. So we chose open ICPSR, and then we will also make it available in the GLR, which is the repository that can be linked directly to the HRS within the MICTA enclave. So because we know that users want that data there. And so we did a couple of different repositories just to make it easy for users.
Yeah, I also deposited my data with the geographic linkage repository that MICTA runs at Michigan. Because it links, I already linked to HRS, but because it additionally links to the panel study of income dynamics and the National Health and Aging Trends study.
I love how everyone is thinking about their users and how to make things accessible and easy to access. Okay, before we move on to questions, one sort of last question for everyone. Looking back, what's one thing you wish you had done differently when developing your contextual data product? And what kind of advice might you give based on those experiences?
Yeah, I have a quick answer to this question. So I started this over 10 years ago with an R21 funding from NIA. And I was like a new postdoc, then a new professor. I think I wanted to do everything all at once, and it really creates a bottleneck in the process. I now know to do the best I can on a thing and then move on to another thing or get a first version out and then improve it. And I think that aligns very much now with my philosophy of if I'm going to generate data, I need to get it out into people's hands or their computers or whatever as soon as possible. It's just not the way we think in science, like that incremental kind of work, but actually career advice for early career people, incremental is usually the best path. But definitely for data generation, I think we don't have to do everything. You don't have to get every database, every variable. You can put out minimum data sets to start with, just to, kind of get the process going. And it feels good when you're a data producer to send it off out into the world.
Any other thoughts there from folks on the panel?
I think I'm gonna echo what Calley said in her presentation about documenting everything, all of your decisions. That's not something we did early on. And I think when you write down, why you coded a variable a certain way or why you decided not to include a specific variable, it actually saves you a lot of time because sometimes we find ourselves having the same conversations about, oh, should we go back and include this variable? But we had already, come to a conclusion that we didn't want to include it for, whatever reason. So I think documenting everything along the way, whether that gets released in a user guide or not, is very helpful and something that should be pretty consistent. And then another thing that we've learned, which might, be obvious, but just making sure you have the right people on your team. So there are some data sources where, you think you might be able to figure out, but what you really need is a legal scholar to help you really understand what the measures are and what are most meaningful for analyses, right? Same thing with, you might need a criminologist or someone who's more familiar with, police department budgets, right? To get back to which of those values are implausible or not. So just making sure you have the right group of folks makes a big difference.
Audience at this point, anything people would like to ask our panelists? All right.
I'll ask a question.
Yeah, please do.
Selfishly, I would like to know how this group manages to track usage of the contextual data sets. I have found this to be way more difficult than tracking usage of, HRS or PSID. Any insights from the group? I mean, we have a recommended citation in our code book, but it doesn't seem to translate.
I could actually chime in here about this. People may or may not cite the citation. I actually, even with with WLS, we really struggle to keep track of actual usage of the data. And what we do, quite bluntly, is but this requires resources, is literally tracking in Scholar Google, and just kind of keeping on top of that to the extent that we can, at least because people don't always cite the data. And you can track data downloads as well, obviously, but that's that also has real limitations. But I'm curious what other folks have to say.
Yeah, piggybacking off of Pam's response, I set up like a Google Scholar alert, not with the citation for the data, but just with contextual data resource. And then we get emails if someone has used that in a site in their paper, right? So sometimes it's not our data sets. So you do have to do a little bit of weeding through there, but that can be helpful to see if people are publishing or not, especially if they're not using the suggested citation.
But I think this also goes back to what Heidi talked about in choosing a repository. So the MICTA's GLR is supposed to be tracking metrics. ICPSR obviously does a phenomenal job tracking metrics. And so I think maybe that's one of the factors that should go into a decision matrix about which repository to distribute your data through.
ICPSR tracks downloads or publications from the data. I mean, I can track downloads.
Yeah, so ICPSR tracks downloads, and then we all use kind of manual or web scraping techniques to track publications. But I actually think ICPSR has started tracking multiple metrics and not just downloads.
And I think
Catherine just put something in the chat.
Yeah, very helpful.
Okay. Should we, I'm looking at the time. I know we have like 5 minutes, but I'm thinking we should probably wrap up. Oh, Catherine says that that's only for the curated data, not the open ICPSR repository. So just for clarification. But yeah, let's just wrap up. And I want to, today thank everyone who joined us for the webinar, all of our attendees, also our speakers, Calley Fisk and Heide Jackson, and our panelists here in this room, Jennifer Carras-Montes, Taylor Hargrove, Jennifer Alshire, and Pam for moderating the Q&A. So we're going to have a recording of the webinar on both of our different networks, websites. We both have our own YouTube channels. So if you go to each of our websites, you'll be able to see this. Probably it'll take a couple of days for our project coordinator to get that formatted and uploaded and things like that. So give us a little bit of time. But we hope that the presentations and this discussion provide a useful guidance on how to build contextual data products that are not only well documented and secure, but also reusable and impactful for the broader research community. So thanks again for being a part of the conversation, and we look forward to connecting with you in the future.